IPSec, IP security, meaning you're going to protect IP packets. That's the meaning. Protecting IP packets, IP security, securing IP. Now, this IP security is not only to protect the traffic on the physical interface, it is also used to protect the virtual interfaces, like tunnel interfaces. You will find this IPsec not only in security domain, you will also see in enterprises. SD-WAN uses IPsec. IPv6 uses IPsec. So we should not conclude by saying IPsec is a security threat. We want protection. So we cannot wait for a security engineer to come and protect. According to me, it should be a part of networking. Both service provider enterprises, everyone needs security. Data center people also need security. So when we talk about IPsec in general, what mostly people talk about is site-to-site VPN. But that's not the only IPsec VPN. But to begin with IPsec, I would like to start with IPsec site-to-site VPN. IPsec can also be used with MGRE, which is what we call as DMVPN. IPsec can also be used with GET VPN. IPsec is also used with various other tunneling techniques. So when we say IPsec, it is not just one type of VPN. IPsec is protecting IP. Protecting IP in physical interface traffic, protecting IP which is going in virtual interface traffic. Can be any physical or virtual. So the name will vary, the approach will vary, but basically the protection needs some protocol. That is what we are going to focus. So those things will be very clearly explained in the site-to-site VPN. That's why I'm talking site-to-site VPN as the first IPsec VPN topic. IPsec. To provide IP security, we need protocols to encrypt. Because encryption is one way of securing data. The other way is hashing. The other way is providing integrity to the data. The other way is setting a lifetime. For rekeying. See, when you keep changing the keys of your bank account or your card that you use to withdraw money, you feel secure. Likewise, the keys that we use to protect our data also need to be changed often. You can set it like 5 minutes, every 5 minutes you change, or every 1 hour you change, or every 24 hours, which is default. So these are the protocols that is used to provide that security to secure our IP traffics. For encryption, there are various protocols. DES, triple DES, AES. In AES itself, you have a much stronger version, little lighter version. AES is very strong, but you have the strongest AES also with different bits used, like 128, 256, something like that. So for encryption, you got algorithms. Depending on your need, you can choose one. DES is weaker, only 52 bits involved in providing encryption. 3 days is 3 times of 56. Sorry, 3 times of 52. AES 128, you have 256, you have. These are all algorithms for encrypting your data. What is encrypting data? Mixing your data with a lot of junk values, you can say, so that when someone receives, they will not be able to read. Yeah, they will not be able to read the data. And the actual receiver only can read it. Because the sender and receiver, before encrypting, they agreed on the algorithm that they will use for encryption. So using that, when you encrypt, the receiver knows with what to decrypt, because earlier we have discussed it with the sender. So the middle guys who don't know what is agreed on cannot decrypt it. What if the middle guys uses different algorithms and try decrypting it? One thing is it won't take that. It won't be easy. That not easy. It will take a lot of time. By the time the session will get over, the rekeying may happen, so that won't be useful for them, even if they decrypt. Another thing is, we are not just going to stop by encrypting, we are going to hash it as well. Hashing, no others can open the hashed packet other than the destination, the actual destination. Hashing is not just encryption. Hashing is generating some value, and when the same value is received on the other side, then the receiver accepts the packet, hoping that it has not been altered. Hashing is not like encrypting and reverting back as decrypting. You cannot reverse hashed data. You cannot reverse. Even the receiver cannot reverse. Hash is to provide a guarantee that it has not been altered. Encryption allows the data to be decrypted. The hashing value that is sent along with the encrypted data guarantees the receiver that this has not been altered. You may decrypt it. The hashing, not just password. It uses time, means the session ID, the domain ID, many things to hash. When it hashes, it uses many things. So within a time period, it needs to reach the destination, and only then hash is going to be used. Otherwise, hash will fail. So if someone in the middle tries to do something, they cannot achieve in a within the session. It won't be useful for them. Integrity is also similar to hashing. Like integrity is also an algorithm which provides integrity, meaning which guarantees the receiver that this packet is not tampered. So for hashing, we have MD5, SHA. In SHA itself, we have different levels. For integrity, we have an algorithm called Diffie-Hellman algorithm, where the algorithms are called as group 2, group 5, group 7, group 15, and so on. More bigger number you use, more stronger the Diffie-Hellman algorithm to provide integrity. Again, more processor. If you go more stronger, then more processor. We should understand that. Fine. So rekeying, you can set the timer, how often the key need to be exchanged, new key need to be generated, and then the authentication type. Authentication type, you have two types. One is using the certification authority. We call it as PKI, public key infrastructure, or pre-shared key, PSK. You might have come across this PSK, PKI. That's what we have as an authentication method. So these all are involved in providing security to IP. But when you talk about site-to-site VPN, this is done in two levels. They call this two phases. Two phase. In phase one, we don't encrypt the data, but we encrypt, we hash, we provide integrity only to the key. The key that will help you to identify the correct destination. See, we are trying to form tunnel, means VPN, means security tunnel, means we are trying to send and receive traffic on the public network. But before we send to someone, we need to first of all identify that he is the right person to receive. Is he really who he say who he is? He says that I am so and so router from this company. You need to find out. You need to check whether his credentials are true. What if someone spoofs? So to provide that, assured peering. All these protocols are used to authenticate, to evaluate whether we are forming tunnel with the right person or not. Once you identify that the person is genuine, the right one, then you are very confident and comfortable to speak to that person now. You're comfortable to speak to that person with less security. You need not to be this much secure. You already found that you are talking to the right destination by authenticating. Now, when you send your data, you need not to be too strict because you already identified that he is a confidential person. And now you have tested him in all manner, and he's sitting with you now. Now you will not hesitate to share things. You will still have some cautious feeling, but you will not be that strict like before. Same thing. This is phase one. In phase two, the data is sent between the peers between whom the phase one was successful. And when you send the data, you send based on the phase one information. Phase one might have given you the session IDs after authenticating. Phase one might have given you the identity to identify the peer. Using that, you are going to send the data to that identity that is given by phase one. You need to simply transfer the data now to that particular peer with whom you found genuine peer. So in phase two, we do only two things: hash and encryption. Hashing and encryption. So in phase two, what we are going to do is we are going to transform our data by hashing and encrypting the data, both. Or you can have any one of this. See, you have an option only to encrypt or only to hash or to do both. Again, in hashing, you have multiple options. You can use SHA or MT5. In encryption, again, you have DES, 3 DES, AES, so on. So you have various options to transform your data. Again, more stronger you use, more process it is going to be utilized. So you need to be aware of all those things. So we got phase two: hash, encrypt, or any one of this to the data. We call it as transform set. The set defines how to transform the data. With what algorithm I'm going to hash and encrypt and change the data so that no one in the middle can understand. First of all, no one can receive it because you are sending to the peer with whom the phase one is successful. So that's why the security guys, when they teach like as if they are civil engineers. They'll say, you already put one tunnel. This is phase one tunnel. Very strong. No one can tamper and come inside and see what is going inside the tunnel. This is how they will speak, okay? Even I was speaking like this in the beginning days, in 2009 period. And this is phase one tunnel between site 1 and site 2. And you got big public network in the middle, and you have put the tunnel between site 1 and site 2. Now inside this tunnel, no one can see. Now inside this tunnel, you are going to negotiate between the sites that I'll use SHA for hashing and 3 days for encryption. And both of them will agree. See, this second phase negotiation happens inside phase 1. To establish the second tunnel inside the first tunnel, the negotiation happens inside the first tunnel, which is identified as secure tunnel. So that the second negotiation that we make, no one will be listening. That is how they make us understand how this works. But actually, whatever is the output of phase 1, phase 2 uses. So that it will not talk to some spoofed person, it will talk to the right peer. Okay, now site 1 and site 2, they have identified each themselves in the phase 1. Using that, they negotiate phase 2. That's what the actual reality is. If you sniff a packet, you will see only encryption and encapsulation. There is no real tunnel. It's just an encryption and encapsulation is what people interpret it as tunnel. So we don't have any tunnel. So inside this phase 2, the phase 1 negotiation, inside the phase 1, phase 2 negotiation happens. When both agree to follow the same algorithm to transform the data, this means all set, ready. The tunnel is ready. You can now use the tunnel to pass the traffic, for which you need a mapping agent kind of thing. You need to map the traffic. You need to map the traffic, for which we will write an access list. So that only those traffics that matches the access list source and destination can use this IPSec service. In a layman term, they will say, security guys will say, only those source and destination packet can go through the tunnel. As if there is a big tunnel made of Birla super cement. That's how they'll speak. With confident, they'll speak Birla super. Anyway, so when a match is found, they are eligible to use the service. To say this, you need a folder, you need a mapping agent. So what we are going to have is, we are going to have something called crypto map. This is the map which is going to map, it's a mapping agent, it's going to map all the traffic that need to be cryptographic, means encrypted. So inside the crypto map, we'll say, this is crypto map is for IPSec, ISEC AMP. What does it mean? ISA KMP is phase 2. Sorry, phase 1. Phase 1. IPSec is phase 2. Means data is getting encrypted, no? So phase 2. So we are saying here you have a phase 1 and phase 2, and this phase 1 parameters are already defined, which will be used by phase 2. Now if you have a phase 2 which is matching with this transform set, in phase 2 we defined transform set. If you find a traffic which matches with ACL, you need to use this transform set which is already tied up with phase 1 and provide security. So whatever the transform set says, if transform set says you need to hash it with MD5, so now data has to be hashed. If transform set says you need to hash as well as you need to encrypt with AES, then now it is going to be encrypted with AES. And then only it will be sent. So only for those traffics that matches the ACL, all these things will be put into one mapping on a folder called crypto map. At last, this crypto map actually will have a number. This number you will call under the router's exit interface. Traffic is coming in here from somewhere in the LAN. Before going out of this router, before it goes out, it needs to take the action. So we call this crypto map under this interface, so that when any traffic goes out, it will match with the ACL. If the ACL is matched, then it will apply this transform set to those data. Else it will go normal. So we are keeping a watchman on F00 with a file saying, before sending anyone out, check with this file. If the person going out matches with this file information, files data, you need to provide him special service. You need to send him with BMW car, bulletproof, with 2 pilots in the front and 2 pilots at the back. If not, just send him whatever he has got. He may be going by walk, he may be going by bike, let him go. But if match happened, he is supposed to go in a bulletproof car, and it should be a BMW or Land Rover. That is the job that crypto map, that's a file I'm talking about. The security guys having a file, crypto map. The security guys should stand on the gate, not behind the building. That's why we apply the crypto map on the interface. That's all the story is. Ask me a question, I'll make it more clear. As of now, I'm good. Okay, have you seen the configuration side of this?
Yes, I did.
Yeah, I've seen. Okay.
The point is, because I did not work on it, I don't remember actually.
You want to see me doing, or how is it?
Yes, yes.
Okay, let's